The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to the first Domer Pramet online training. My name is Martin Sehnal and I'm Product Operation Manager for Domer Pramet in North America and also a host for a show we are running today. Just a note on the side, you can write your questions anytime during the presentation. For that, use your webinar panel on your screen. We will try to answer all your questions at the end of the presentation. In case we are running out of time, we will make sure we provide you a written answer later during the day today. One more note, we're sitting in the Elgin, Greater Chicago area, so that's from the start. And now I have with me in the studio Gary Kirchhoff, who is a product manager for Domer Pramet in North America, and he will be our presenter for today. So Gary, stage is yours.
Okay. Good morning, everyone. Okay, this presentation will explore the basic tapping and provide a brief introduction to our Dormer ANSI Shark Tap product range. Safety is everyone's responsibility. Always maintain a safe work environment and be aware of safe zones and exits in case an emergency arises. The first step in selecting the right tap for the job is to determine the market area you're working in. This starts the process of narrowing down the types of products we should be looking at. Our standard tap range can be grouped to best address these three market areas. The top of the triangle represents large-scale production. This area focuses on high productivity. Our Dormer ANSI Shark Taps made from a premium high-speed cobalt powder metal substrate should be used to best address these material-specific applications. The Dormer Shark Taps are the best in our range, offering the highest possible productivity to manufacturers that quantify their savings in terms of productivity or cost per hole. The middle section represents the mid-market or medium-sized production. In this area, we focus on large to medium-sized job shops where many of the taps used are multi-material type taps. Union Butterfield DIN ANSI Applix taps and mid-market ANSI, DIN, and ISO taps are available for this market area. This market area will also welcome higher productivity when it can be measured and documented, or the versatility of the taps is recognized and appreciated due to the wide variety of materials that can be addressed with the same product. The bottom section represents the economy market. In this market segment, construction sites and tool rooms perform maintenance and repair applications. Here, price and perception are the main factors that determine the taps used. For this market area, we recommend our Union Butterfield and Dormer general purpose hand and spiral point taps. The quality of high performance and coated products cannot be gauged here because the heat generated in machine tapping applications is not a factor. Here's another way to look at tap selection and how the Dormer Pramet range has you covered. The graph on this slide illustrates the tapping products used from the smallest batch sizes where typically hand tapping and drill presses are used, up to the highest production runs where optimal tool performance is required. We had identified a gap in our range and the need to fill that gap with a higher performance level DIN ANSI material specific range of tapping products. Dormer Pramet is now proud to introduce a new and better range of taps dedicated to material-specific applications. We will go over this newest range of DIN ANSI Dormer taps later in the presentation. The next step is to select the right type of tap geometry for the operation. Each of these tap geometries are available in the different groups to best address the market area you are working with. Spiral point taps are recommended only for tapping through holes because they push the chips forward out of the bottom of the hole. The stability of this type of tap makes it suitable for most materials. Spiral flute taps are used primarily for tapping blind holes, but can be suitable for through holes in machine applications. The chips are evacuated backwards and are directed up the spiral flutes and out the top of the hole. Straight flute taps are very sturdy and strong taps, but with less thread depth capacity. These are mainly used for short chipping materials that are evacuated from the hole with coolant pressure or compressed air. Forming or roll form taps are designed to cold form internal threads. The material is displaced, so no chips are formed. The best results are obtained by using good lubricating oils in conjunction with this type of tapping operation. Always remember, a tighter tolerance on the pre-drilled hole is necessary when using forming taps. The pre-drill is a different or larger size than when using cutting taps. Okay, the spiral point tap has straight flutes, resulting in increased strength for fast tapping. The spiral point design feature forces the chips forward, and the flutes are only intended for conveying the lubricant to the cutting teeth. The main features are, it's the strongest tap style available, it's suited for very tough conditions, pushes the chip forward and out through the bottom of the hole, thus it's only recommended for through holes, and thread depths up to 3 times diameter are possible depending on the tap style used. The spiral flute tap is a very versatile tap design, since it can be used in both blind holes and through holes. The spiral flute forces the chip backwards up and out the top of the hole. The main features are the most common tap style used in CNC machining. The helix drives the chips backwards up through the flutes and out of the top of the hole. No chip packing is possible at the bottom of the hole. And the tap is suitable for blind and through holes, but machine tapping is recommended on through holes due to the smaller chamfer sizes on these taps. Thread depth is usually up to about 2.5 times diameter. The straight fluted tap design is still widely used, but the straight flute does not permit good chip evacuation, and therefore this tap has limitations in machine applications. The main features are thread depths typically up to about 1.5 times diameter. It's the best choice for short chipping materials like cast iron. It's often used in the automotive industry, for example, engines and castings. It can be used for all types of holes. Be aware that additional space is needed at the bottom of the pre-drilled hole to hold chips when tapping blind holes. In hand taps are for manual and machine tapping of through and blind holes. Hand taps do not direct the chips to flow in any certain direction. Chips will curl in the flutes and break on their own, or may require the taps to be rotated 1/4 to a 1/2 turn in the opposite direction to manually break the chip. For manual tapping, straight type tap wrenches or T-type handle tap wrenches can be used depending on the clearance around the tapping area or the amount of torque required to turn the tap. Fluteless or forming taps do not have any cutting edges, but they have a series of lobes instead. They are designed to cold form internal threads. The material is displaced as the tap is screwed into the material. Because the material is displaced or formed, the pre-drill hole is larger than the pre-drill hole for a cutting tap. The main features are, it's a chip-free tap solution, suitable for soft steels, soft stainless steels, and non-ferrous materials, suitable for high-volume machine tapping operations, can be used for all types of holes and depths. Usually higher cutting speeds will result with these, and deformation gives a higher strength of thread produced. Because that material is displaced, the thread is much stronger than when you're removing the material. Note, a forming tap with lube grooves is always preferred over the non-groove type, as grooves will help to carry lubrication into the hole. Another important step to proper tap selection is to determine the type of chamfer or lead your tap should have. All taps will typically have a chamfer or lead. This is the number of imperfect threads counted from the end of the tap until the first complete or perfect tooth form comes into play. Here we'll look at the types of chamfer leads that taps can have. There are various icons that represent the chamfer on a tap, and these are shown on this slide. The taper lead chamfer is the longest tap chamfer type and allows for easier starting with less torque. This chamfer type is commonly offered on hand taps and allows for more gradual cutting until the first perfect thread is reached. Taper chamfer taps are typically used for materials that are more difficult to machine. A larger number of imperfect threads share the load and gradually ease the tap into the workpiece. These taps are not recommended for blind holes unless there is plenty of clearance at the bottom of the hole to accommodate the imperfect threads and the collection of chips. Note how the measurement of the chamfer does not include the length of the male center if it exists on a tap. Male centers are typically used in manufacturing tap sizes up to about 3/8. Above 3/8, taps are normally produced with internal or female centers and will be flat on the end. The plug lead or chamfer is the most common type in the industry and is used in both hand and machine tapping applications. This type of chamfer lead does not require as much clearance at the bottom of the hole for imperfect threads, but is still not ideal for blind holes. This chamfer type is most often found on spiral point taps and is mostly used for tapping through holes. The semi-bottoming chamfer lead, also known as C form, is a common solution for blind holes as it only leaves 2 to 3 imperfect threads at the bottom of the hole. Due to the lower number of imperfect threads, there is more load that is put on the first few teeth, causing a higher torque per tooth. When hand tapping, these are not the best choice for starting new threads, as it is much more difficult without the longer chamfer lead to start the thread so it runs true. In most cases, a taper chamfer lead tap will be used first, and then the remaining threads at the bottom of the hole will be cleaned up using a semi-bottoming or a bottoming tap. The full bottoming chamfer or lead, also known as E form, has the least amount of imperfect threads, allowing you to thread very close to the full hole depth. Again, due to the lower number of imperfect threads, there's more load that's put on the first few teeth, causing a higher torque per tooth. When hand tapping, these should not be used for starting new threads, again, as it is much more difficult to start the thread so it runs true. In most cases, a taper chamfer will be used first, and then the remaining threads at the bottom of the hole can be cleaned up as a secondary operation using a semi-bottoming or bottoming tap. The workpiece material is selected based on the function of the component, and the tools needed to machine the part are not often considered. The machinability of the material will result in an increase or decrease of the component cost. The tools needed to machine the part will factor into this component cost. Some of the factors which influence the products selected for tapping are the type of material, the size, and the shape of the workpiece, the type of hole being threaded, whether it's a through hole or a blind hole, the thread specifications, whether it be a UNC, UNF, M, MF, NPT, etc., the accuracy and fit of the thread, meaning the class of fit or the H limits. It's important to understand that the function of the threaded hole is based on the full thread depth or length of engagement. The length of thread engagement with your threaded fastener is illustrated here. The length of engagement increases the thread's strength. The thread on the right will be stronger due to the number of threads engaged. The greater the thread depth, the larger the thread tolerance. In other words, a tap hole having normal 2B class of fit with longer thread engagement can actually be stronger than a tighter 3B class of fit with short thread engagement. Similar to that, deep holes with longer thread lengths allow for smaller thread percentages. Again, the longer thread engagement increases the strength of the thread, even if the thread percentage is lower than the thread percentage on a shallow hole. Thread percentages are determined by the diameter of the pre-drilled hole, or the minor diameter. Class of fit is usually specified on the part print. The 2B class of fit is the most commonly specified fit, but aerospace parts and other more accurate applications do require sometimes a tighter 3B class of fit. Larger, oversized thread limits can also be specified, like H7 or H11, sometimes when the workpiece will be heat treated or plated after tapping. Always try to use the largest possible drill to achieve the thread percentage desired. A thread percentage of 75% resulting from a smaller hole size will increase the load and torque required to tap the hole and will result in less tap life than a thread percentage of 65%. Sometimes by slightly increasing the drill size to allow a lower thread percentage can drastically increase the tap's tool life. So this can be a very effective way to achieve higher productivity. So the hole size required is somewhat based on the full thread depth required. Longer thread engagement can allow for a fit that's not as accurate than what would be needed on a shallow hole. The drilled hole size is determined by the thread size required. The two tables on this slide show you the hole tolerances based on your tool material and the amount of oversize you will drill based on these hole tolerances. The table on the left shows the actual hole tolerance that can be achieved when using different types of drills. The drill substrate and design will determine how accurate the pre-drilled hole will be. The table on the right shows the expected oversize condition that is probable using the different drill types from the other table. As shown, the oversize amounts will increase as the drilling diameter increases. Note how in the H12 columns, and that would be using a standard high-speed steel drill, it shows the hole oversize condition can range anywhere from 4 thousandths on the smaller drill diameters up to as much as 8 thousandths on the larger diameters. This oversize condition is already factored in when selecting high-speed steel drills from most tap drill charts. All of this information and a lot more can be found in our technical section of our round tool catalog. There are several ways to calculate the thread percentage. This is based on your pre-drilled hole size. To save time, we have provided PDF files showing a way to calculate thread percentage for both the cut taps and forming taps. The normal thread percentage for cut taps should be approximately between 65% and 75%. Any more or less could compromise the thread strength or severely affect your tool life when tapping. The normal thread percentage for forming taps should be approximately between 55 and 65%. The calculated thread percentage will be much less on formed threads due to the material being displaced or formed instead of being removed or cut. Remember, when using high-speed steel drills to pre-drill your holes for tapping, the resulting hole size will always be larger than the drill size used. Tap drill charts already take this into consideration when they recommend the drill size. So if you measure the actual hole size created with a high-speed steel drill, it will be larger than the drill size you used to create the hole. When using a solid carbide drill, the resulting hole size will be much closer to the actual drill size used. So you must allow for this when pre-drilling with solid carbide. If you drill with carbide using the size shown on your tap drill chart, the resulting hole size will be too tight. The resulting thread percentage will be extremely high, and the tool life of your tap will decrease dramatically in most cases, or the tap could break. The choice of substrate or tool material that a tap is made from is based solely on the application and purpose. High-speed steel taps are suitable for tapping workpiece materials up to about 32 Rockwell C. Cobalt, which is HSSE, or powder metal, HSSPM, or cobalt powder metal, which is HSSEPM, taps are suitable for tapping materials up to about 45 Rockwell C. Workpiece materials that exceed 45 Rockwell, some examples are like AMG 1.7 to 1.8. These are best addressed when using solid carbide taps or thread milling. Remember, tapping the holes in a workpiece is very often one of the last operations performed, so this makes tapping the holes a very critical operation. Choosing an inferior tapping product could result in scrapping a very expensive part due to all the other operations that have been performed prior to cutting the threads. In 2017, we introduced our new Dormer High Performance DIN ANSI Sharp Taps. To illustrate the largest benefit to the customer, it is important to put the emphasis on the high performance aspects and productivity. Our global R&D design expertise, coupled with state-of-the-art manufacturing, has created one of the best tapping solutions in the industry with the Dormer Shark program. Some of the features in the program, these taps are color ring coated. The color ring on the tool shank identifies suitability for certain specific materials and enables quick and easy tool selection. Advanced geometry, a significant reduction in axial forces and torque compared to the conventional taps. This ensures problem-free threading of blind and through holes in the selected materials. DIN ANSI standard. Standard ANSI shank and square sizes coupled with the DIN overall length for extra reach and compatibility with inch standard tap holding. And special edge treatment is applied to increase strength and reduce the chance of microchipping on the cutting edges. This considerably improves the performance and tool life. Dormer Shark taps are produced using a unique cobalt powder metal substrate, HSS EPM. All Shark taps are manufactured from a unique cobalt powder metallurgy tool steel, different from any other substrate. This produces an unbeatable combination of toughness and edge strength, allowing the taps to perform at higher cutting temperatures while offering excellent performance and longer tool life. Looking at the microstructure pictures on this slide, you can see that the carbides in the material used for our Shark taps are finer and distributed much more uniformly. This gives the new substrate a 30% higher impact toughness at the same hardening temperatures. This higher impact toughness is especially needed in threading applications. But the impact toughness is only one component of the cutting ability of the material. Another key component is the high hardness properties. Combining the new HSS EPM substrate with the coatings specified further enhances the performance of these products. A little bit about the coatings. The TIALN top coating is applied to our yellow, red, and white Shark taps. This is a PVD multi-layer ceramic coating which has been through a post-coating smoothing process. It exhibits high toughness and oxidation stability, making it ideal for higher speeds while also improving tool life. Our Super B coating is applied to our blue Shark taps. This is a hard lube coating in which the high hardness and temperature resistance of TILN is combined with the outstanding frictional and lubrication properties of a WC/C, which is tungsten carbide carbon surface layer, to allow for smoother chip flow. It's especially beneficial when threading tough, long chipping, heat-resistant materials such as stainless steel. The Blue Shark designs are the only DIN ANSI Shark taps that offer this type of coating on top of the HSS PM special substrate. Blue Shark taps offer excellent performance even when cutting temperatures reach to almost 1500 degrees Fahrenheit. A little overview of our program. The yellow Shark taps are for structural steel, plain carbon steel, and low alloy steels. The DIN ANSI yellow Shark range includes spiral point or plug style and a 40-degree spiral flute design, coated with TILN top to offer dependable solutions in numerous softer steel applications. The red Shark taps are for alloy steels. This DIN ANSI red Shark range includes spiral point or plug style and a 45-degree spiral flute tap coated with TILN top to offer dependable solutions in these harder alloy steel applications. The blue Shark taps are for stainless steels. The DIN ANSI Blue Shark range includes spiral point and 40-degree spiral flute coated with Super B with an additional edge treatment to offer dependable solutions in stainless steel applications. And the white Shark taps are for cast iron. The DIN ANSI White Shark range consists of one style of straight flute taps coated with TILN top to offer dependable solutions in cast iron applications. These are available in semi-bottoming chamfer and in the full E-form full bottoming chamfer with coolant through, which facilitates chip evacuation by hitting the bottom of the hole and flushing chips backwards up the flutes. The features and benefits of the DIN ANSI Spiral Point Yellow Shark taps. These taps, again, are for high production tapping of through holes in carbon steels, electrolytic copper, and its soft, long chipping alloys. The feature and benefits are the HSSE PM substrate, providing an unbeatable combination of toughness and edge strength, allowing higher cutting temperatures while offering longer tool life. Again, the TILN top coating with a post-coating smoothing process to enhance the chip formation and chip flow and to prevent built-up edge. The positive geometry with a high rake angle and relatively low radial relief angle. This specifically developed for steels with low resistance and resilience like plain carbon steels. The modified edge treatment is applied to increase the cutting edge stability for longer tool life, reduction of risk of chipping, and to ensure process security and improve thread quality. This edge treatment gets rid of all the unwanted burrs on the tap after it has been ground, but before the tap is edge treated or coated. The yellow ring on the tool shank helps us to recognize the tap as being specifically suited for tapping softer steels, copper, and brass. The ANSI Spiral Flute Yellow Shark taps are very much the same features and benefits. These are for high production tapping of blind holes in carbon steels, copper, and copper's soft long chipping alloys. Similar features and benefits to the Spiral Point style, Yellow Shark is designed to pull the chips up and out of the top of the hole with the spiral flute. Features and benefits of the ANSI Shark Red Shark range. These taps are for high production tapping of through holes in the harder alloy and tool steels. The same HSS PM substrate, TILN top coating, positive geometry with a high rake and radial relief angle, which was specifically developed for alloy and tool steels with medium to high strength. Again, it has the modified edge treatment, and the red ring on the tool shank helps us to recognize this tap as being specifically suited for tapping harder alloy steels. The features and benefits of the ANSI Spiral Flute Red Shark, basically the same as the Spiral Point Shark, the Red Shark, but again, the spiral flute is designed to pull the chips up and out of a blind hole. Features and benefits of the ANSI Spiral Point Blue Shark. These taps are for high production tapping of through holes in stainless steel. This is probably the best stainless steel tap on the market today. The same high-speed steel powder metal substrate is used. This one has the different coating. It has the Super B over the TILN hard loop coating, combining the hardness and temperature resistance of TILN with exceptionally low frictional coefficient thanks to a WC/C surface layer. This allows better chip flow and reduces the risk of built-up edge. This has, because of the materials addressed, this has high cutting positive geometry, a very specialized modified edge treatment on these taps, specifically geared towards stainless steel. The blue ring on the tool shank helps us to recognize the tap as being specifically suited for tapping stainless steels. Class of fit. The Blue Shark series for threading UNC and UNF threads is available in both 2B, which is a normal fit, and 3B, which is a closer class of fit. Class 2B threads offer optimum thread fit and balances faster performance, higher production, economy, and convenience. Nearly 90% of commercial and industrial fasteners use this class of thread fit. Class 3B fits are suited for close tolerance fasteners. These fasteners are intended for service where safety is a critical design consideration. This class of fit has restrictive tolerances and no allowance. The Spiral Flute Blue Shark is very much the same, but the Spiral Flute design pulls the chips up and out of the blind hole. Same as on the Spiral Point Shark, the Spiral Flute UNC and UNF Blue Shark taps are offered in both 2B and 3B classes of fit. The ANSI Straight Flute White Shark taps are for cast irons. The same substrate, the same TILN top coating, very strong geometry on this product with low rake and radial relief angles, which provide the necessary edge stability for cutting cast iron. The modified edge treatment is present, specifically geared towards these small chipping materials. And a white ring on the tool shank helps to recognize the tap as being specifically suited for tapping cast iron. The features and benefits of the straight flute white shark taps with through coolant. This is for tapping blind holes and cast irons at the highest level of productivity and process security. These full form bottoming coolant through taps offer the same features and benefits of the solid non-coolant type, but are designed to flush the chips out of the hole. Through coolant with axial outlet reduces the interruption of the production process for providing optimum chip evacuations in both horizontal and vertical blind hole tapping. There are three basic rules to keep in mind when tapping. Well, actually, there's a lot of rules, but there's three that are most important. The pre-drilled hole quality has a direct influence on tool life. Always be sure to select the correct diameter for pre-drilling. The formula to calculate the tap drill hole size includes a factor for the desired thread percentage, for example, 65%. Should a customer require a 70 to 75% thread instead, that factor will reduce the drill diameter. Be careful though, because there is a limit. When you're drilling a pre-drilled hole with a high-performance, high-speed steel or cobalt drill like ADX or PFX, or if you're using a solid carbide drill, CDX and ForceX, as illustrated earlier, these will produce holes to a tighter tolerance than standard high-speed steel drills. So you need to ensure the hole diameter is sufficiently large. If the diameter of the hole is too small, the tap will wear prematurely or the tap will break. When a tap breaks, it's almost always a result of the torque becoming too high. During the lifespan of a cutting tap as well as a forming tap, the torque increases as a result of the tap's cutting edges getting dull. It is recommended to use tapping attachments that are equipped with a safety clutch to prevent breakage and to allow the user to safely use a tap to the end of its tool life. It is possible when pre-drilling for blind holes, we recommend to include a safety distance or at least 2 extra threads at the bottom of the hole. If a tap hits the bottom of the hole when tapping, the tap will definitely break. Cutting fluids are also very important in a high-performance tapping process. It's not only that coolants increase productivity, it also improves part quality and dimensional accuracy. This concludes our online training course number 1, Tapping Basics. Join us again next month on February 23rd for training course number 2. This next training course will be about indexable tools, and it will be focused on tool wear and Pramet grade selection. Thank you for attending today.
Okay, so we have one question actually, and Gary, so would you recommend the blue shark tap for tough, longer chipping materials such as Inconel?
The blue shark tap can be a secondary selection for Inconel, but we will be introducing more products to add to this family, and super alloys will be one of the target areas that will be coming in the future.
The next question is that blue shark tap is suited for stainless, but what about cast stainless?
In cast stainless, yeah, it depends on the type of material. Normally, yes, I mean, the blue shark will operate very well in AMG groups 2.1, 2.2, and 2.3. If you get into your harder 17.4 pHs and those types of stainless, then you may have to look at our HMD Union Butterfield tap for the exceptionally harder materials.
And how practical is to utilize our tapping cutting fluid while you're on CNC machine where fluid or through coolant is readily available?
If you have flood coolant available on your machine, or better yet, through coolant for like the White Shark taps, definitely I would use the machine coolant. You can get much more force, you're much more likely to pull that coolant down into the tapped hole.
All right, so that's about it. No more questions. Thank you very much for your attention, and we're looking forward to seeing you next time in 3-4 weeks. Have a good day. Bye.
Thank you.